I'm going to talk here about graphing rose curves. So rose curves either are going to look like r equals a number a times sine of n theta, or r equals a number a times cosine n theta. The a is going to tell us what we call the radius, that is how far away from the pole or the origin can the curve get, and the n is going to tell us the number of petals. So if n is odd, then that's going to be the number of petals. And if n is even, then that means we're going to get 2n petals. There'll be twice as many petals as that number. So I'm going to work a couple of examples here. First one I'm going to graph is r equals 2 sine theta. So the first thing we can see is because of that r equals 2, the a is 2, that means that our curve is going to be at most 2 away from the pole or the origin. So I'm going to graph a dotted circle of radius 2. That's going to be the boundary of my curve. So the curve is never going to be any more than 2 away from that pole or origin there. So the next thing I want to know is where's the end of the first petal. So the end of the first petal is going to be when this sine 3 theta is the first time, it's the first angle that makes it the biggest that it can be. So that is, the largest sine can ever be is 1. So we are looking for the angle theta that first makes sine equal to 1. So sine of pi over 2 equals 1. So that means the 3 theta must equal pi over 2. So then if you solve that for theta, we'll divide by 3 or multiply by 1/3. That means that theta is going to be pi over 6. So at theta equals pi over 6, then that's when our sine 3 theta will first equal 1. That's going to be the end of our first petal. So I'm going to go here to an angle of pi over 6, which is roughly there. So I'm going to say there is theta equals pi over 6, and I'm going to make that be the end of the first petal. So I'm going to put a little green dot there. Now, we know that the spacing for petals, the spacing is going to be even, and since the 3 was odd, the n was odd, that means we have 3 petals. Since they're going to be evenly spaced and 2 pi is all the way around the circle, then there will be a distance, a spacing of 2 pi over 3 between each petal. So that means that the next petal, since our first petal is at pi over 6, the second petal is going to be at pi over 6 plus the 2 pi over 3. That's the spacing. And so if we get a common denominator, since 2 pi over 3 is 4/6, that's going to get us to 5 pi over 6. That's going to be the end of the second petal. So I'm going to go to 5 pi over 6. That's going to be somewhere about right there. And where that, so when theta is 5 pi over 6, sine 3 theta will be equal to 1 again, and we're going to be as far away from the pole or the origin as we can get. So then the third petal, I'm going to go add another 2 pi over 3 to the last one that I had. So there's the 5 pi over 6 plus another 2 pi over 3. And since 2 pi over 3 is 4/6, that's going to give us 9 pi over 6, which is going to reduce to 3 pi over 2. So that means at the angle 3 pi over 2, that is going to be where the end of our third petal is. So I'm going to put a green dot right there on that circle of radius 2. So now we can see the 3 green dots are going to mark the ends of the 3 petals. then it doesn't really matter, but the way you can draw this to kind of see how the path will be traced out is I'm going to start at the end of the first petal. I'm going to look 180 degrees across the circle and then go counterclockwise to the end of the next petal. So that's right here. So I'm starting at the first one. I'm going to draw an arc that goes through the pole and connects to the end of that petal. Then I'm going to look 180 degrees across from where my pen is right now, and I'm going to go counterclockwise to the end of the next petal, and I'm going to connect the end of that petal, the end of those two petals, by going through the pole. And one more time, I'm going to go through the pole and connect to that first petal, and the idea is that's going to be our 3-petaled rose curve. So it is a 3-petaled rose curve. Okay, so I'm going to go to a new page and do a different one so you can see a little different look. So for this one, I'm going to say r is equal to 3 cosine 2 theta. So a couple different things here. I've got a cosine curve instead of a sine curve. I've got the radius is going to be 3, and because the n is even, then that means we're going to get 2 times that is 4 petals. So we're going to have 4 petals on our curve, and our radius is going to be 3. So I'm going to draw my axis, and I'm going to make a dotted circle of radius 3. That's going to be the boundaries of our rose curve. So the edges of our petals are going to lie on that circle. And then I'm going to connect those. So like before, we first want to find the end of the first petal. And the end of the first petal is going to be when our cosine 2 theta is first equal to the biggest it can be, and the biggest a sine or a cosine can be is 1. So we want to solve for theta when cosine 2 theta is equal to 1. Now we know that cosine is equal to 1 when theta is 0. So we're going to set the 2 theta equal to 0, divide by 2, and that means that the end of the first petal is going to lie on the angle theta equals 0. So there's our angle, theta equals 0, and when that runs into our circle, that's going to be the end of our first petal. So then we're going to find the spacing between petals, and to do that, we are going to take 2 pi, that's a full circle, and divide it by the number of petals, which in our case is 4, and if we reduce that, that's going to be pi over 2. So I'm going to take our first petal, the end of our first petal, 0, and add the pi over 2 to that, and that's going to be the end of our second petal. And so I will go to the angle pi over 2. That's going to put us up here, and I'll put a little green dot where that intersects the circle. There's the end of our second petal. And likewise, the third petal, I'm going to take where we left off, the end of that second petal, and that was pi over 2, and add our spacing, which was pi over 2, and so that's going to put us at 2 pi over 2, or pi. So here we are, here's our angle pi, and at the end, where that intersects our circle, is the end of our third petal. And then the fourth petal, we're going to just do it again. So we'll take where we left off, the pi, and add another pi over 2 to that, and that'll give us 3 pi over 2. So that is going to be the end of our fourth petal, and there's our green dot. So again, to connect them, I'm going to start at the first one. I'm going to look across 180 degrees, then turn my eye counterclockwise to the next petal. So I'm going to connect these 2 petals going through the pole. So it's going to look something like that. And then likewise, I'm going to go 180 degrees, slide over counterclockwise to look at the next petal, and I'm going to connect those by going through the pole. And again, going 180 degrees, going over clockwise, connecting that one. I'm going to go through the pole, and finally, one more time, and you see our 4 petaled rose. Okay, so that's the idea for rose curves, and I'll leave it right there.